Application of elastic collision. Application of elastic collision. Okay. The theory of elastic collision in one dimension. The theory of elastic collision. Elastic collision. The theory of elastic collision in one dimension. In one dimension. One dimensions is applicable is nuclear reactor is applicable is nuclear reactor is nuclear reactor. Okay, nuclear reactor. Okay, in a nuclear reactor in nuclear reactor, hydrogen is used as a moderator. Hydrogen is used as a moderator. Hydrogen is as a moderator or stationary target. Okay, or stationary target. Okay, for slowing down the neutrons, for slowing down the neutrons, produced by the fission of uranium atoms. Fissions of uranium atoms. Okay, so as to enable them to produce more fission. Produce more fission. Okay, fissions. Okay, 92U235 uranium atom plus 0 and 1 neutrons. Arrow mark of 92 uranium atom 236. 92 uranium is also converted in uranium atom 236. Arrow mark of 56 barium. 236 plus 56 krypton. 92 plus 3 neutrons plus energy released in 200 mega electron volt. Okay, this obvious because the hydrogen nucleus, the proton has nearly the same mass that of neutrons, and hence in a head-on collision with a hydrogen nucleus at rest, the neutrons are thus almost brought to rest, are greatly slowed down the special case second and at articles in previous. If a massive nucleus like that of lead were to be used as the target, the neutrons will simply bounce back from it with the same velocity with which they imping on it. Okay, imping on it. Okay, thank you.
Kinetic energy of M1 before collision M1 equal to M1